Hi everyone, this is Dr. S. Welcome to the first in a series of videos introducing the first topic in Year 13 Organic Chemistry for OCR A-Level. Particularly this topic is about aromatic chemistry. And particularly what we mean by aromatic is something called a benzene. Now benzene is one compound, but we often use the word benzene to mean parts of a bigger series of compounds. One of the tasks I'm going to set you to go away and do is to actually research how benzene was discovered and how the structure of benzene was determined. Now throughout these videos what I'm going to do is I'm going to set you a few challenges and ask you to pause the video between them so you can have a go at the challenges, and then I will go through how I would answer them. So the first challenge I'm going to give you is a reminder from year 12 about empirical formula. So I have a question here related to benzene, which is a hydrocarbon has a percentage mass of carbon of 92.31% and a percentage mass of hydrogen of 7.69%. Its MR is 78. Can you calculate the empirical formula and the molecular formula? I'm going to ask you to pause the video and then come back to it once you've had a go. Okay, good. I'm glad you've had a go at that. I'm now going to go through exactly what I would do in order to answer this question. So if I just open my calculator on my other screen. Okay. So what I would do is I would think I have carbon and I have hydrogen. And I know that it's 92.31% of carbon and 7.69% of hydrogen. So if I was imagining 100 grams, that would be 92.31 grams of carbon and 7.69 grams of hydrogen. What I can then do is work out the number of moles of each one. So if I do 92.31 divided by the atomic mass of carbon, which is 12, then I get an answer of 7.6925. I will do the same thing for hydrogen. Hydrogen's atomic mass is 1. So I'll divide that by 1 and get an answer of 7.69. And you should be able to see straight away that they are very similar. What you would do in terms of an empirical formula calculation, of course, is divide by the smallest to find the ratio. But hopefully you should see there that the ratio here is 1 to 1. In other words, the empirical formula is CH. So now it comes to the molecular formula. Well, the MR of a carbon and a hydrogen put together, so the MR of the empirical formula is 13. But I know that the molecular formula has an MR of 78. So what I need to do is work out how many times the empirical formula goes into the molecular formula. So what I would do is I'd do 78, which is the MR of the molecular formula, divided by 13, which is the MR of the empirical formula, and I'll get an answer of 6. That means that the empirical formula is multiplied by 6 to get the molecular formula. So the molecular formula is C6H6. That is the molecular formula of benzene. Now it's quite unusual in the fact that it's got the same number of hydrogens as carbon. Now benzene was discovered in the 1820s, and it puzzled scientists for decades about what its structure would be. I'm going to ask you to try and replicate those decades and come up with an idea of what structures might have the formula of C6H6. You're going to have to think about your year 12 organic and think about the sort of things that can reduce the number of hydrogens in a molecule. So I'm going to end this first video. I'm going to ask you to have a look and see if you can come up with 3 or 4 possible different structures that would have the molecular formula C6H6. And I'll see you in video 2.